Imagine folding a piece of paper like this. You take a simple sheet and fold it in half, bringing the two ends closer together. Now, imagine a tiny ant, Chotusar, trying to crawl from one end to the other. The ant has to travel the entire length of the paper, which seems like a long journey for such a small creature. It'll have to travel the whole length, right? Step by step, it moves forward, inching its way across the paper. But what if, picture this, what if there was a shortcut? What if you could fold the paper in such a way that the ant could just step across? Like you fold the paper and the two ends meet, making a tunnel for the ant. Suddenly, the long journey becomes a short hop. That, my dust, is a wormhole, a cosmic shortcut through space and time. It's like a magical tunnel that connects two distant points in the universe. Wormholes are like tunnels, imagine, that connect faraway places in space, letting us travel super long distances in a jiffy. Imagine being able to travel from one galaxy to another in the blink of an eye. These shortcuts, they're like something out of a sci-fi film. Scientists and storytellers, everyone loves them. They spark our imagination and make us dream of incredible possibilities. They make us think of a future where traveling to other stars isn't just a dream, but a real thing. Imagine exploring new worlds and discovering the unknown. This whole wormhole idea, it comes from Einstein's theory, the famous scientist. His equations suggested that such shortcuts might be possible. He said gravity is like bending space and time because of heavy things. Imagine a heavy ball placed on a stretched rubber sheet, causing it to bend. Wormholes are still just a theory. We don't know for sure if they exist, but just imagine the possibilities. If they do exist, they could revolutionize our understanding of the universe. Could we travel faster than light? Could we break the ultimate speed limit of the universe? Could we even travel through time? The idea of wormholes opens up so many fascinating questions about the nature of reality and our place in the cosmos. This wormhole idea, it started in 1916 with a scientist named Karl Schwarzschild. He was a brilliant mind, delving deep into the mysteries of the universe. He found something interesting in Einstein's equations, like a puzzle piece that didn't quite fit. It was a revelation that would change our understanding of space and time. He discovered that a super heavy object, so heavy it's unimaginable, could bend space and time so much that it creates a point of no return. A singularity. This singularity is a place where the laws of physics as we know them cease to exist. This singularity, it's like a hidden place, covered by something called an event horizon. The event horizon is the boundary beyond which nothing can escape. Nothing, not even light, can escape from it. This is what we call a black hole. Black holes are some of the most mysterious and powerful objects in the universe. But here's the twist. Schwarzschild also found a hint of something else, a white hole. A white hole is the theoretical opposite of a black hole. Imagine a place where things can only come out, never go in. It's like a cosmic fountain, constantly ejecting matter and energy. This white hole, connected to the black hole by a tunnel, that's what they called an Einstein-Rosen bridge, the first idea of a wormhole. This concept suggested a shortcut through space-time. Imagine two whirlpools going in opposite directions, joined by a small channel. This channel represents the wormhole, a potential pathway through the fabric of the universe. That channel, my friends, that's like an Einstein-Rosen bridge, a path through space and time. It's a fascinating idea that has captured the imagination of scientists and science fiction writers alike. Sounds amazing, right? But there's a problem. These theoretical bridges are incredibly unstable. These bridges, they wouldn't be very safe for space travelers. The gravitational forces inside a wormhole would be extreme and chaotic. The gravity would be so strong, the wormhole would collapse before you could even blink, making it impossible to go through. This makes the idea of using wormholes for travel a distant dream, at least for now. The biggest problem with wormholes is keeping them open long enough for a spaceship to go through. Imagine trying to walk through a door that slams shut before you can even step inside. They're like those automatic doors at the supermarket, closing too fast. You need to time it just right, or you'll be stuck on the wrong side. To stop a wormhole from collapsing, scientists think we need something special, exotic matter. This isn't your everyday kind of matter. It's something truly extraordinary. This exotic matter, It's like something from a magic show. It has negative energy. Imagine a magician pulling a rabbit out of a hat, but instead, he's pulling out something that defies the laws of physics. That means it has less than zero energy, and its gravity pushes things away instead of pulling them in. It's like an invisible force field that repels everything around it. Imagine a ball on a trampoline. When you place the ball on the trampoline, it creates a dip. The ball is like normal matter, and the trampoline is like space and time. The weight of the ball distorts the trampoline, just like how matter distorts space-time. Now, imagine a weird ball that makes a bump on the trampoline instead of a dip. This is what exotic matter does. It creates a sort of anti-gravity effect. That's exotic matter. It bends space and time the opposite way, maybe giving the push needed to keep a wormhole open. It's like having a magical key that can hold the door open for you. This exotic matter, it's still just an idea. We haven't found it yet. Scientists are on the hunt, theorizing and experimenting to see if it can be discovered. But some scientists think it might exist in extreme places in space, maybe near black holes. These are the most intense environments in the universe, where the laws of physics are pushed to their limits. If we could find and use this exotic matter, we might just unlock the secret to wormhole travel and start exploring the universe like never before. Imagine the possibilities, new worlds, new civilizations, and perhaps even new dimensions waiting to be discovered. Section 4. Finding hidden passages, detecting wormholes. So, how do we find these hidden cosmic shortcuts? Right now, we haven't seen any wormholes with our telescopes. They're hiding somewhere in the vastness of space, but that doesn't mean we can't find them. Scientists have some clever ideas to find these hidden passages. One way is to look for something called gravitational lensing. That's when the gravity of a big object, like a galaxy, bends the light passing by it. If there's a wormhole between us and a distant star, its gravity would bend the star's light in a special way, leaving a clue that we could see with powerful telescopes. Another way is to look for Hawking radiation, a faint glow that black holes are supposed to have. Section 5. Zoom. Faster than light wormholes and faster than light travel. Wormholes aren't just about connecting faraway places, they might also let us break the speed limit of the universe, the speed of light. Einstein said nothing can travel faster than light, but wormholes could be a clever trick. By taking a shortcut through a wormhole, we could travel faster than light, even though we're not actually going faster than light inside the wormhole itself. Imagine a spaceship going into one end of a wormhole and coming out the other side a few moments later, having traveled light years in a blink. But traveling faster than light brings up some tricky questions about cause and effect, like, what happens if you go back in time and change something? Section 6. Time twisters, wormholes, and time travel paradoxes. Time travel through wormholes, that's a real head-scratcher. If we could travel through time, things could get really complicated. Cause and effect could get all mixed up, and the past, present, and future could become a big jumble. There's a famous puzzle called the grandfather paradox. Imagine you go back in time and accidentally stop your grandfather from meeting your grandmother. If your grandfather never had kids, then you wouldn't exist. So how could you have gone back in time in the first place? It's a puzzle, isn't it? This grandfather paradox shows us how tricky time travel can be. Section 7. Other worlds, wormholes, and the multiverse. Faster than light travel and time travel are already mind-blowing, but wormholes might also lead to other universes. The idea is that our universe might be just one of many, each with its own rules. Some scientists think wormholes could be like doors connecting these different universes, letting us see places beyond our wildest dreams. Imagine going through a wormhole and ending up in a universe where gravity is weaker, light is faster, or time goes backwards. This idea of many universes, it's called the multiverse. It's still just a theory, but it's gaining popularity among scientists. If other universes exist, wormholes might be the key to finding them and understanding the cosmos in a whole new way. As we continue to explore space, who knows what amazing things we'll find hidden in the fabric of space and time.